In this video, we're going to be taking a look at Netgear's GS108Ev3 network switch. It's an 8-port switch, which is part of their Plus management range. And what this means is that if you want to separate your computers, and you should for smart home devices in particular, you'll be able to configure VLANs on this switch. Now, if you buy an unmanaged switch on the other hand, you'll need to buy additional switches for each network segment. So while managed switches do cost a little bit extra upfront, they can save you money over the longer term. Energy efficient ports are another useful feature of this 1 gig switch, but what's it like to configure, and is it worth considering? Now, like most network switches which are aimed at small offices and home users, this switch is managed through a web browser. Now, what IP address you actually point your web browser at really depends on how you've set this up. So for example, if you plug this into your existing network, it'll obtain an IP address through DHCP. So you'll need to point your web browser to whatever IP address that the actual switch was leased. On the other hand, if you've just got this network switch sitting on its own and you've plugged a PC into it, you'll need to point your actual web browser to the built-in IP address of 192.168.0.239. However, you will have to actually configure your computer with a static IP address that's in this range. So for example, 192.168.0.100. Now the first thing to point out is that the connection from the PC to the actual switch is not secure, just like the web browser is pointing out. But it's not even encrypted because we're using HTTP to connect to this switch. If I try to switch it over to HTTPS instead, in other words, I tell it I want to use an encrypted session, it just sits spinning its wheels because it's not actually supported as an option. So that's something to bear in mind because we need to log into the actual switch to manage it. We need to put in our password. That needs to be sent from our PC to the switch. And if anybody can intercept the communication, they'll be able to read the password and then potentially they can actually log into the switch. Now, for home users, for instance, that may not be a concern, but it is something for business users to consider, especially because the biggest security threats are actually internal. So do bear that in mind, as that this is not an encrypted session. Now, another thing to point out is that if you want to log in and manage this switch, all you need to do is to supply a password. Now, security is all about layers, so really we want to see an actual user account here as well. In other words, you need to know what the user account is and the password to be able to log in. Now, granted, there are systems out there where there is only one user account and you can't change it, but ideally we do want 2 items of information that you need to supply to make logging in more difficult. Now, in order to log in for the first time, you need to supply the default password, which, not surprisingly, is password. So we'll type that in and click on login. And the first thing it does is tell you to actually change the actual default password. And it gives you like options down here. So I'm going to put in a password. I would suggest putting in something a lot more complicated and a lot longer than what I'm using. Use a password manager, for example. We'll click on change password. It's telling us that the actual password's been changed. It's giving us the option here to register the actual product. At this stage, I'm not going to do that just for the sake of this video. So I'm just going to click on remind me later. But now we should be able to log in and manage this actual switch using that changed password. Now, once you've logged in, the first page that you're actually placed onto is this system management switch information one. So this gives you some options here where you can change the switch name. So by default, it's just set to the actual product ID. We can get the serial number, we can get its MAC address, bootloader version and firmware version. Now, typically when it comes to network infrastructure, you'd actually want things like a switch, for example, to have a static IP address. So I would usually disable that option for DHCP. So that's useful that we can opt between DHCP or static IP addressing. But what you would do is change that, click apply, and then you would start connecting using that different static IP address going forward. Other pages that we've got here under management are port status. So this gives us information about the actual ports, what state they're in. So at the moment, for example, the only port I'm using is port 2, and that's what my computer's plugged into. And you can see that it's running at 1000 meg, in other words, 1 gig. You can either select all of the ports, or you can select an individual port. Now, the only things you can change are the actual speed and the actual flow control. Normally, flow control doesn't get used. Speed would be something you would change if, for example, you've got a computer and it's just not working with auto negotiation for whatever reason. So you've got various options, anything from like 100 meg all the way down to 10 meg if that's still getting used. But that is a useful option. The other thing to bear in mind though is that the MTU size is fixed. In other words, the switch is set up to support jumbo frames. So in some respects, it's a good thing because it means that if you've got computers and you want to use jumbo frames, you don't have to actually make any changes to the switch itself. Typically, the problems that occur is when the actual PCs are trying to communicate with each other and they've got different MTU sizes. So I suppose in this respect, it's just saving you from having to administer the actual switch as well. So it's one less thing to think about. Another page that we've got here is for loop detection. Now, this makes sense if you're going to actually have a series of switches plugged together. So if you've got more than one switch and you connect them together, it's possible to create a bridging loop. And when that happens, well, it brings the network down. Now, by default, it's disabled. So what you can do is enable that. And that would make a lot of sense, actually. So I'm not sure why they haven't got that enabled by default. And then we've got switching modes. So this is where you can either manage it through the web browser, which is the default, or you can also manage it through a web browser in Netgear's Plus utility. Now, under the maintenance tab, we've got a series of options. The first one is to change the actual admin password, and it does have an extra security check here. So you do need to know what the existing password is in order to be able to change it. So that's useful if, for example, you were to leave this web browser open. If somebody were to walk by, they won't be able to change the password without knowing what it already is. There's an option to reboot the device, so it's got an extra check for this one. So you've actually got to select the option, then click apply. So you don't want to accidentally just reboot the switch by mistake. Similarly with the default settings option, where you can reset this back to its factory defaults within the actual web browser without having to physically go to the actual switch itself, I suppose, which is useful. We've got an option for firmware updates. Now, the only thing to bear in mind with this one is you've got to go into what it's referring to as loader mode. When it does, it then gives you an option to upload the actual firmware software. Now, the only catch with that is I couldn't find a way to back it out without forcing an actual reboot of the switch, which is a bit inconvenient, I must admit. But what it does mean is you can't just literally point it to the internet and pull an actual latest version of the software down. You've actually got to upload the software to the actual switch locally. So you'd have to download it from your PC through a web browser, and then you'd have to upload it to the actual switch. You've then got options to save your configuration and restore your configuration, which is always sensible to do. You always want to keep a backup of the actual configuration. So whenever you make a change, I would recommend saving your configuration. Then if something were to go really wrong, you can always restore it. The only thing to bear in mind is you're probably going to have to find a way to actually tweak your actual web browser, because web browsers have been getting a lot more security conscious, and what they do is, well, they cause problems when it comes to trying to download software or files of any nature, for that matter. This one in particular on this switch, what I'm noticing, I'm using Microsoft Edge. If I click on the save button, it comes up and saying this file was blocked because it might harm your device. If I click on here, I've got a choice though. I can just say, well, yeah, okay, I'll keep that. So at least it's pulled the actual configuration file down and it has stored it locally. So that's just something to bear in mind, is that these web browsers can get a bit fussy. Now, there's not a lot to be expected when it comes to monitoring of network switches like this. So what we've got here is a page for port statistics. So we can get to find out how much traffic's going in and out of a particular port. More useful though is the CRC error packets. In other words, if you've actually got a computer and it's having network problems, you can check here to see if that counter's going up. If it is, then chances are you've either got a cable fault or an actual problem with the network card, or maybe the drivers, for example. Now, if all of these actual counters are going up though, then it could actually be the actual switch itself that's got the issue. Now, these counters are static. I mean, if you go to another page and then come back again, they will change, or you've got the option to refresh them while you're here. You can also clear the actual counters out, which is useful as well. The switch also supports mirroring, so you can pick a port as your actual source port, and then you would need to actually enable the feature and then pick whichever port is going to be the destination port. And there's various reasons why you want to actually monitor traffic on a specific port, so that's a useful feature to have. And then we've got a cable testing option where you can actually run cable tests on a specific port, which is useful for checking for like network cabling faults, for instance. Now, out of the box, this switch provides some basic multicasting support. So we've got an option here for IGMP snooping, and as you can see, that is enabled. And basically what that means is the switch listens out for requests from computers when they want to get access to multicast streams. Now, the benefit of that is that it means that when there's multicast traffic on the network, the switch will learn which actual PCs want access to that multicast stream. It'll only send the traffic then to those specific PCs, and it won't send it to the others. In other words, you won't get traffic flooded on the actual network switch, which is a lot more efficient. We've also got an option to enable the VLAN ID for IGMP snooping, but we haven't actually got VLAN set up, so we can't do anything with that. If you've got IGMP version 3 being used, you can get it to validate the header. And there's also an option here to block unknown multicast addresses. In other words, if you've got multicast traffic on the network and the switch doesn't know about it, it can actually block that, but it's reliant on actually learning that from the actual PCs that are requesting access to it. Now, the main reason for wanting to buy a managed switch is so that you can configure VLANs. In other words, to be able to separate out your computers from each other without having to purchase additional physical switches. Now, this particular switch here offers two options as port-based VLANs and 802.1q. Now, the port-based option is pretty simplistic. It doesn't give you anywhere near the number of VLANs that you'll get out of the standard 802.1q, for instance. So I'd be more inclined to go with 802.1q, especially if you're going to be connecting this switch to other switches that support 802.1q. Now, by default, VLANs are disabled on this switch, but if you want to enable them and you want to use port-based VLANs, then you've got a choice between basic and advanced. So if we go with the actual basic option and select enable, we get a warning that's going to erase the existing settings, so I'll just click OK. And then what you do essentially is just decide what VLAN is going to be used on a particular port, and you've got a choice from 1 to 8 or all. So for example, I could set this one to VLAN number 2, put this one on VLAN number 5. This one, for instance, we could give it access to all VLANs. So that's going to be an actual trunk link, for example, to maybe a hypervisor or firewall. We'll click on apply, and that's made our VLAN changes. Now, if I go to advanced and then click on enable, we'll get the same warning. It's just going to erase the existing settings. By default, all of the ports that we've got are assigned to VLAN number 1. And what you can do is select from VLANs 1 through 8. So I can pick VLAN number 2, for example, and I can allow that on, say, ports 3 and 4. Click on apply. What it means now, though, is that ports 3 and 4 have got access to both VLANs 1 and 2. So you'd have to go back to actual VLAN number 1, deselect those to be able to remove these ports from being able to get access to VLAN number 1, for example. So it is pretty simplistic to set up. I mean, you've got options where you can select every port there, for example, or just remove all ports if you like, just to make it a bit easier when you're picking ports out. But it does mean that it's pretty simple to actually set up. I mean, that all option doesn't really apply here in the sense that you've got a lot more degree of control in terms of what VLANs are applied to each individual port. But I do like the option that you can at least remove ports from using VLAN 1, specifically because VLAN 1 is a VLAN that you shouldn't really actually be using. The only thing to bear in mind is if I go back to the system here, there's no reference in here to actual VLANs as to what VLAN the actual management interface, if you will, belongs to. So that's one concern I do have when it comes to VLANs on this particular switch. I mean, you can see basic VLANs have been disabled because we enabled that feature. So that's just something to bear in mind. You can pick one that just basically wipes out the entire configuration of your VLANs. So you can't just like start setting things up and say basic and then switch over to advanced and have that carry through. It's either or, but it is pretty simple to set up. Now, when it comes to using VLANs in a network, it makes more sense to use the standards-based 802.1q. And this switch is giving us options of either basic or advanced for the configuration method. So for basic, if we click on enable, then just click on OK. By default, all of these ports are assigned to VLAN number 1. And we've got a choice of 1 to 4093 or all. In other words, I can set specific actual ports to belong to certain VLANs, or I can set the actual port to support all VLANs. So for example, on port number 1, I can assign that to VLAN number 2. If we go to port number 4, if I set that to all, then if I click apply, basically what that means is if I were to plug a PC into port number 1, it's got access to other computers that are in VLAN number 2. These other ports that we've got here are assigned to VLAN number 1. They can all talk to each other, but they can't talk to this computer in VLAN 2. I'd have to assign another computer to VLAN number 2 for those two devices. So the two computers in ports 1 and 7 will be able to talk to each other now. Now, port 4 is what's referred to as a trunk port because it allows access to all VLANs. So that's useful if you've got a firewall, for example, and it's got lots of virtual interfaces set up for VLANs. That would then give it access to various VLANs on this network, but with only one physical interface. Same goes for hypervisors. The hypervisor could have virtual interfaces itself. It could also have virtual machines, each in different VLANs, and they can all communicate with any other computer in any VLAN once you've got the port configured with this all option. Now, it's really better to use advanced mode because, for one thing, it allows us to actually control what VLANs an end device has access to. That's particularly true when it comes to things like hypervisors, for example, where there's going to be access to multiple VLANs. We can actually control which VLANs can be used on that hypervisor at the switch level. So it doesn't matter what the actual hypervisor gets configured to use. If, for example, somebody puts a virtual machine on there that's using VLAN 800, well, if the switch isn't allowing access to VLAN 800, well, it's not going to work. So what we need to do is click on Advanced, and then click VLAN Configuration, and then select Enable. Click OK just to confirm that we're going to erase the existing settings. Now, on this page here, which is VLAN Configuration, we can add and remove VLANs, and we can also see what actual ports have access to what VLANs. At the moment, there's only one, which is VLAN 1. So if we create a new one, so we'll put 2 in here, for example, to create VLAN 2, click on Add. If, for example, we don't want a VLAN anymore, we can select that and tell it to delete it. But in our case, we want to use VLAN 2 as an example, so we'll put it back in again. Now, let's say we want to set up a PC that's plugged into port 4. At the moment, it's in VLAN 1, and we want to change this over so that it's got access to other computers in VLAN 2. In which case, we need to edit the port settings, basically, and give port 4 access to VLAN 2. So we'll click VLAN Membership. We'll select VLAN number 2. And then for port 4, if we click it once, it shows U, which means untagged traffic. So we've got a PC plugged in here. There's no tagging going on. So that's what we want, U for untagged. I mean, there is this group operation, for example, where you can untag all of the ports, you can tag all of the ports, or you can remove all of the ports. In our case, we're dealing with untagged traffic. The PC and at least as far as expectations go, is it's not going to be using any tagging. Switch isn't going to be using tagging either when the two talk to each other. And we don't really want to give it access to anything other than VLAN 2 anyway. So that's why we're setting it to U for untagged traffic. We'll click Apply, go back to VLAN configuration, and you can see that port has now got access to VLAN 2. Now, we really shouldn't be using VLAN 1. So as we're making these changes to ports, we should be removing them from VLAN 1. VLAN 1 is really intended for system traffic. That's the best practice. Leave it for switches that talk to each other on VLAN 1. It's a better security practice. There's always the potential to get around VLAN. So the recommended practice is do not use VLAN 1 for any of your computers. So we need to remove VLAN 1 because at the moment it's got access to VLAN 2 and 1. So if we go back to VLAN membership and then click that button once, and then again, we're now showing an unselected port. So that means it's no longer going to have access to VLAN 1. If we click on Apply, the only problem it's saying you can't remove it from the VLAN because that VLAN is what's being used as what's referred to as the PVID, the primary VLAN ID. In other words, if we go to port PVID here, we've got all 8 ports, and by default, their PVID primary VLAN ID is set to 1. This is how the switch deals with untagged traffic, which what you run into with 802.1q. If a computer were to send untagged traffic to the switch needs to know what to actually do with it. What VLAN should I put this traffic into? And by default, it's VLAN 1. Now, in this particular case, you're dealing with an access port. The computer shouldn't have access to anything other than VLAN 2. So what we want to do is change this. So we'll select that port, change its PVID to 2 so that it matches the VLAN that we actually want the traffic in, and then click Apply. Now, granted, in this case, the PC won't be sending anything tagged anyway, but this is just something you need to bear in mind, is that until we change that PVID, we can't remove it from having access to VLAN 1. So now that we've done that, it's now deselected, and when we click Apply, it shouldn't have access to VLAN 1 anymore. So if we go back to VLAN configuration, at least you can see now that port number 4 is set up as what's known as an access port. The only thing it's going to have access to is VLAN number 2, and that's exactly what we want. Now, if you have a computer which needs access to multiple VLANs, so for example a hypervisor, then we need to set up what's known as a trunk port, in which we actually exchange tags between the switch and the actual hypervisor so that they can actually know what VLAN the traffic belongs to. So first thing I need to do is to create a new VLAN, because we're going to set this hypervisor up to have access to VLANs 2 and 3. Then we'll go over to VLAN membership, pick VLAN 2, and then for this particular port, we set the option to T because it's tagged traffic. Click Apply, and then we'll do the same for VLAN number 3. And if you go back to our VLAN configuration, we've now got port 7 set up so that it's got access to VLANs 2 and 3. Now, the only thing is it's still got access to VLAN 1, and we need to remove that as part of a best practice. Now, the only thing is, when it comes to devices that have got access to multiple VLANs, in other words, when we've got a trunk port, it's also a best practice to not to have any untagged traffic, in which case we need to be able to have a means to actually deal with any traffic that comes across as untagged, and this switch doesn't have an option to actually drop or block access to untagged traffic. Now, in that case, what we need to do is to set up a completely new VLAN, one that isn't going to get used. So I'm going to create one. I'm going to call that 900 and click on Add. We need to actually give the actual hypervisor access to VLAN 900. But because it's untagged traffic, we select the U option instead of the T option and click Apply. If you come back to VLAN configuration, you can now see it's now got access to all 3 VLANs. But what we want to do is go to the port PVID page, change that primary VLAN ID to 900, click Apply, and now we can actually remove access to VLAN number 1. So if we go back to our VLAN configuration page here, you can see that we've got access to VLAN number 2, VLAN number 3. Now this is going to be tagged traffic, which is what we expect. Ideally, we shouldn't be seeing any traffic coming across that doesn't have a tag. If it does, it'll actually end up in VLAN 900, which isn't being used. And the idea is don't plug any computer into VLAN 900. Don't use it at all, because what we want to see is tagged traffic and tagged traffic only. And that's how you would deal with it on a switch like this. Now the switch has some basic support for quality of service, or QoS. And you'll find that under the QoS tab and then under QoS here. So by default it's set to 802.1p/DSCP based, otherwise you can pick port based. Now the default option does make more sense, especially if you've got hard phones or video devices out there that support DSCP packet marking, for example. Otherwise you can have port based. If you select that, say yes to erase the existing settings, what you can do is you can give certain ports higher priority than others, for example. So by default, everything is set to a low priority, but we could pick port 2, for example. We could give it a normal priority, medium priority, high priority, but you've got to be careful in terms of which ports you give priority to others. This feature, on the other hand, the 802.1p, it's very basic. It applies to all ports. So if any traffic is coming through ports that's got these actual QoS markings, then that type of traffic, particularly the voice and the video traffic, for example, will get elevated privileges when it's being sent out of port somewhere else off the network to another port, for instance. So it is very, very basic. There's not a great deal you can do with it. So normally you just leave it on that default setting. Now another basic feature that this switch is supplied with is rate limiting. And you'll find that under QoS and then rate limit. Now, what you can actually do with this on a per port basis is set the ingress rate, in other words, the amount of traffic that's allowed into the port, and the egress rate, the amount of traffic allowed out of a port. So if we were to pick port 1, for example, I can actually restrict this. So if I were to plug a PC in, for example, and it's a 1 gig link, what I could do is I could restrict it to say 512 kilobits per second, all the way up to 512 megabits per second. It doesn't really pay any attention to the actual connection speed that's currently being used. So this one, port 2, for example, I know it's running at 1 gig. It doesn't change. So the reason for using something like this, though, is if you've got a computer, so for example, maybe it's been compromised, maybe it's got a virus or malware on it. Typically PCs don't really send that much traffic, but if it's been compromised, you might see a lot of traffic suddenly being pushed towards the actual switch. What the switch can then do is it can actually rate limit how much traffic it'll accept. Now, it doesn't stop the PC actually sending, at a full 1 gigabit per second. It just restricts how much traffic the actual switch itself is actually going to accept from that PC. So it is useful, I must admit, but it is still a very basic sort of feature, in that it's really up to the actual PC to then decide whether to back off or not. Now, it is still beneficial in the sense that all the rest of that traffic, all that excess traffic, would actually get dropped by the switch, and you'd only get a small amount then getting forwarded out to the rest of the network. So there is still some benefit to it. Now, the final feature to cover is broadcast filtering, and you find that under QoS, broadcast filtering. Now, this is similar to rate limiting because it's intended to actually deal with situations where a computer gets compromised, for example, and it just starts sending out a lot of broadcast traffic, hence the name broadcast filtering. Now, if you enable this feature, you need to be very, very careful because it can actually cause problems for your computers. But what you can do is pick a port and you can set a limit as to how much broadcast traffic will be accepted. So we've got a range from 512 kilobits per second to 512 megabits per second. With Cisco switches, for example, they typically recommend you would actually enable a feature like this for security reasons so that you can actually deal with that sort of situation. And you would set the actual limit to about 10%, but you'd have to experiment. So maybe you might want to set it to, say, 128 megabits per second for 1 gig links. See if that's okay and just leave it at that. Otherwise, maybe you want to actually increase the amount. But the idea is that if a computer does get compromised that broadcast traffic that maybe would have been being sent out at line rate and getting sent all over your network to all of your computers and causing problems would actually be reduced by having a feature like this enabled. So it is definitely something useful to have just in case. So overall, what do I think about this switch? Well, for somebody like me who has a lot of computers that need access to lots of different VLANs, I do prefer to be able to configure any VLAN on any port all on a single page. Now, with this type of switch, you actually assign ports to one VLAN, and that means for somebody like me, it is actually quite time consuming. But once it's all set up and configured, maintaining it going forward isn't that much of a problem. And if you're just going to be plugging PCs into this actual switch and then assigning a single VLAN to the ports, you won't have that issue. I think my only concern really is just that the actual security of the switch could have done with more attention. There isn't a user account, and that would have been beneficial, especially if you could be able to actually change that user account. But it's the lack of encryption that concerns me the most. Having said that, what I have since found out is that it'll only accept management connectivity on VLAN 1, so that is a step in the right direction. But if somebody can actually intercept connectivity to the switch, well, the actual password's in plain view, which isn't a good thing. So what it comes down to basically is that if you're a small office user or a home user, then it does actually make a good entry-level switch. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, as that'll help get the video out to more people who might find it useful as well. If you've got any comments or suggestions, please post those in the comments section below. And if you're new to the channel and you'd like to see more content like this, then yes, do subscribe. Just remember to set the bell icon to actually send you notifications when new content gets released, although I also post to Twitter as well as Facebook. If you'd like to help the channel and support it, you can actually make contributions through PayPal and Buy Me a Coffee. I've also got links to Patreon, and there's also the join membership option for YouTube itself. Patreon and YouTube members do have the option to actually benefit from early access as well. But above all, many thanks for watching this video. I'll see you in the next one.